Thanks, Harsh. Okay, I don't know if y'all saw recently, but there was news articles about. There's a reason I brought this up. There's news articles that DeepMind had about artificial intelligence, specifically the AGI, the artificial general intelligence. And so I'm going to give you a little reminder. Like I had a Mind Garden, you can go look it up. I think I recorded it. And in the Mind Garden, it's talking about like what do we mean by artificial general intelligence as opposed to just regular artificial intelligence or artificial superintelligence. So when we talk about artificial intelligence now, it's machine learning. It is specific that you are trying to basically find statistical anomalies or statistical certitude around different facets or different things. So you're trying to research. So any of the linear regression type stuff is just, that's what we call artificial intelligence. I think it's a bad name for it because it really is not really intelligent. It is just trying to find statistical pattern and then saying, this is what we've learned from that pattern. Artificial general intelligence was a little different. General intelligence means that we have created machines that aren't just designed to solve a specific problem in this linear regression way, but are designed to think and behave in the same way that we think and behave. So they can solve broader problems the same way we solve broader problems. And the concern about that has been brought up is once you do that and you have a machine that's able to do general intelligence, then that machine will be evolving much faster than we will. And pretty quickly that machine will outpace us. And that's what they call the superintelligence. And it was up to the concern back in January of 2015, there was a letter that was created that was signed by a bunch of artificial intelligence experts, including Stephen Hawking and Elon Musk, saying, if we do this, if we create general intelligence, then we want to somehow embed a respect of human life in this general intelligence. Because in a few short generations, it will be looking at us the way that we look at chimpanzees. And we don't really have a great track record on how we treat chimpanzees, right? Yes, exactly it. And so while it's science fiction, I mean, these people are genuinely concerned that when we do this, it may be, they call it the singularity, technological singularity. There's no going back. Like, it will take over. It will now become the predominant species, I guess you would call it, on our planet. And we want to, and that's what this open letter is about. It's about trying to make sure that it has a respect for human life. So that way we can continue to proceed. In fact, it's not up here, but Elon Musk's Neuralink, right? If you've seen Neuralink, Elon Musk, he's using it now for paraplegics and quadriplegics to give them the ability to think and then move external arms and systems and stuff. But he actually, the whole reason that's just to make it commercial so that you can get money from it and it can become a viable thing. What he really wants to do with Neuralink is he wants to make sure that we can enhance our brains with technology so that we can keep up with these super intelligent machines. That's what Neuralink exists for, right? Even though it has its commercial purpose now. Yeah, and so this is Elon Musk giving his concern about it. Now, the way that they plan on doing general intelligence, as we talked before, is to mimic our brain, right? And what they believe is that our ability to think, the way that we think, is because of an emergent property of the complex interaction of the neurons in our brain. So if we can and we kind of understand how neurons work, if we can get a system that mimics neurons in the way that our brain mimics them, and does it at the same number that our brains does them, then that's when the super intelligent machine is going to be created. That's the point of singularity. And they are working on this right now. This is a whole branch of artificial intelligence research is to create this. This was, I don't know what the current number is, but at one point they were able to have a machine that simulated 1 billion neurons in the brain, which is great, but our brains actually have 100 billion neurons with 125 trillion synapses, right? We're not close to mimicking that yet, but the whole point is the technology is there. It's just a scaling issue now. If we can scale up, then they think that's how we're going to reach this. Yeah.
So is a zettabyte on that 100 trillion scale? Bytes?
I'm not even sure what a zettabyte is. I don't know why I put this up there. This was from my last talk before.
Is that true, Kirkby? Like, I feel like, is it just a matter of scale? Like, do we actually know enough about the brain? I kind of feel like we're kids, like, watching their parents and pretending and doing some of the same things that they're doing and pretending that it's the same thing.
That is a very wise perspective. I would say that a majority of artificial intelligence researchers and a majority of neuroscientists think we do know enough about that.
Interesting.
But
I didn't realize that.
But to your point, I saw a story not too long ago where it was talking about how the timing of the firing of the neurons was transmitting information that the brain is using. And that's a new revelation.
Yeah.
So whether or not we're going to really be able to do it this way, because do we really understand it well enough? We understand these parts fairly well, but that's a really good question. I think that'll come out if they actually do this. But the main point is this is the path, right? If this is true, and there's reasons to believe that's not the case, because one of my biggest problems with that thesis is it's not falsifiable, because the statement is if you have a complex enough brain or a simulation of a brain, if you mimic that complexity, then something's going to emerge from that, either a consciousness or a human-like intelligence or both, right? It's going to emerge. So you create something complex and it doesn't emerge, well, you haven't falsified it. Instead, we have to add more complexity, right? So then you have to study more and more. So it's one of those theories that'll probably last for a very, very long time as they're trying to find it out. Or maybe it's just around the corner and the next thing we know, the singularity happens tomorrow and we're all in zoos, right? So, but that's a good insight. Now this right here is the recent news. This happened, they reported on it 2 months ago, just about. And this is a different insight. And that is, while we're trying to create human intelligence through the mimicking of neurons, DeepMind, which is a Google-funded lab out in the UK, pretty much the height of artificial intelligence, they came out with a paper claiming that you don't need to create neurons and to mimic neurons of the brains in order to have human intelligence, that instead a reinforcement learning model is enough. Right, and when you talk about artificial intelligence, there's supervised models, there's unsupervised models, and there's reinforcement models. And reinforcement models are basically unsupervised models that have reward mechanisms built into them so that you can then turn them loose. And as long as you have the right reward mechanism, it will then create the neural networks that are needed. Not neural networks in the sense of replicating neurons, but neural networks in the sense of having hidden layers, as we know about the neural networks, the existing ones that kind of mimic neurons, but not quite. But that if you do that, if you do the right reinforcement, then it's going to create an artificial general intelligence, right? And that was it's pretty controversial for them to make the statement, but these aren't fringe people making the statement, right? These are people on the cutting edge. And so I'm going to just give you another example. This is from another mind garden I did on genetic algorithms. Genetic algorithms are also reinforcement learning algorithms. But I'm just going to remind you a little bit of this to show you how the reinforcement works. And this was an example that I used in a course I took about a robot picking up cans. And the idea is, over here we have R is the robot, C is the can, and then we have the playing field. And the robot can see left and right, up and down, and can move left, right, up, and down. Those are the actions it can take. It can pick up a can, or try to pick up a can. And then what you do is you have, with all those different possibilities, you just create strategies. And you have a strategy saying, if we see a can north, and we see a empty south, and we see a empty east, empty west, and empty current, then our action is to move north. And that is the full strategy here. In all the scenarios that this robot can run into, we have mapped out an action for it to perform. And with the genetic algorithm, you just randomly give it actions for each of those scenarios. And you then, in the scenarios, this is an example of scenarios that were built out, you just randomly give it actions, and, well, that's not good. You just randomly give it actions, and then eventually, what happens...
You randomly give it a strategy, is that what you mean?
Right, you randomly, so the strategy is taking all the scenarios that are possible and giving it an action for each of those scenarios, and you just randomly assign actions to each of the scenarios, and that's what the strategy is. So the strategy is for that. You do that multiple times, or you come up with like 10 different strategies, and then you run simulations on it. And the simulation then pulls out whatever it is. Now, you can think, if I'm sitting on the right edge of the screen, and there's nothing to the right, there's a wall to the right, and I make a choice to go right, nothing's useful is going to happen. But when you boot up a genetic algorithm, you go ahead and let that happen, right? And you let it run with what's called a fitness function, where you basically say, we're going to now score that if you pick up a can, then you get a point. If you try to pick up and you aren't able to, then you give it a negative points. And if you try to move and unable to, you give it negative points there. And you keep running these strategies. You then run the scores at the end. You say at the end of the simulations, this is the score for this strategy, and you then crossbreed these strategies together. Right? The ones that are at the top, the ones that perform the best, you take like the top percent, and then you crossbreed them. And not only do you crossbreed them, you also just add some random strategies in there. You just throw us what the red are. You just add in a random action at different places in here, and you keep running you keep running the simulation where you're getting the top scores, and you crossbreed them, and then put some randomness in there, and eventually some interesting things occur. When I first did this, I found, instead of building this out myself, I found one online that somebody had created. It was written in C. And I decided to just use that and play around with that rather than write my own. But it was not effective. Their strategy was not effective. The reason it wasn't effective is because they had actually put some cheats in there. So they tried to do a supervision of the model. And the cheat was, well, if there's a can, then you just pick it up. Let's not let the algorithm figure that out. This is picking up a can is a good thing because it's a point. And so what they ended up doing, like in this case, a robot finds a can, picks the can up, and then it sees that there's a can to the right and at the bottom. Its strategy is to go right. It picks up that can, and it continues to go forward, and it picks up all the cans that it sees. Now, at this stage, it doesn't have any information. It has no memory about where the cans were at this point. And so now, it just has to do something random in this case. There's no optimal, clear strategy here. But we know that it's gotten 1, 2, 3, 4 points, right, before it's gotten to this point. But what ended up happening when you actually let the algorithm run, eventually the algorithm will leave cans. Like you see on the left, there's a can that's being left there as it moved right. And what it's actually doing is creating a breadcrumb. It didn't, like you didn't code this in. You didn't say create a breadcrumb. It just automatically found out this was the better strategy because we scored better at the end. And so you can see it's created this breadcrumb now so that in this scenario, it knows, there's a can south, I can go south, picks up the can there, but it doesn't actually pick up that can because, again, it's leaving the breadcrumbs. I think the rule that it comes out with, if you were to define it, which nobody defined this rule, but if you were to define it, it would be if you're on a can and there's more than one can that you can see, then don't pick up that can, move to one of the other cans first. Right. And that's what it ends up doing. So then it creates this breadcrumb trail, and it's able to find its way back and actually pick up all the cans. Right. So that's an example of a reinforced learning model, and it's doing it specifically with the score. The score is a big important thing that you want to do. So DeepMind, the guys who actually created this, y'all probably have heard that they created that they're the ones who've created an algorithm that beats the top chess players in the world. They're the ones who created the algorithm that beat Go players, right? They're the ones who created an algorithm that beats StarCraft.
That was cool.
Yeah, that one was really cool.
I didn't know that.
Really?
Yeah.
Like from scratch?
Uh-huh. Yeah.
Like they didn't teach.
They did a reinforcement
They had no
model.
StarCraft heuristics?
No.
Did they do the same thing as Go?
Yep.
Wow.
Yeah, and now the only downside of that, or the detriment to it, is it was a one-on-one. It's a completely different game when it's a multiplayer game in StarCraft, right? They haven't done that yet, but there's no reason. There's a reason to believe that they are going to be able to do that, right? Yet is the big question, and that's what this says. And this is talking about. So this is a paper that they did when they wrote it, because the AlphaGo that they created was specific to Go itself, right? They were training it for Go. There might have been some heuristics in that for the Go thing, I don't know. But what they ended up doing was create.
There wasn't. I heard they just cut out the rules of Go and said the goal is to win Go. And
So I think, say again?
The first time they had a history of games and they did an AlphaGo 0 that had completely
Yep.
yeah, that's true.
Yeah, so that's what this is talking about. This is, you can see here it talks about AlphaGo 0, but then also in this paper it now talks about Alpha 0. So you're right, it's that second one. Alpha 0 is a general purpose one. So that's the exact same thing they use for chess, for Go, and for StarCraft.
Oh, really?
Yeah.
Just different rewards.
Different rewards, yeah. And these are the people watching one of the top StarCraft players getting eaten by this game. And they said it was the interesting thing is when Gary Kasparov saw it playing chess, he said he was really amazed at the creativity of the player, right? That's a little, I don't know, does that cause you any consternation, right?
What is the quote? It's like any sufficiently advanced technology looks like magic.
Yeah. It's like any sufficiently advanced technology is indistinguishable from magic. Yeah, so it is. It's somewhat magic, but at the same time, he says, because Gary Kasparov was known for his creative play in chess. That's really, it wasn't his technical prowess, it was his creativity in coming up with different solutions. And here he is saying that this robot is creative. Like that's, to me, that's like the last domain that we will have over robots is creativity. Guess what? They may not stay.
But what is creativity anyway? It's just like a positive outcome that you can't explain, right?
I don't know.
If you do something that I didn't think of, then you were creative, right?
Yeah. Or if I do something I didn't think of, like I just don't even know how that amazing thing that popped out of my brain happened.
I think it's so intertwined with the people who are witnessing your creativity, with whatever experience they have as well, right? So I mean, maybe I don't know that it can be defined so completely that way, but maybe not. The main point is, for the artificial general intelligence, they're now telling us that this kind of reinforcement learning is something that can happen. We don't need to actually mimic the neurons in the brains, and this technology exists now. But what they're doing with it. So I have DeepMind up here. This is, to me right now, this is indistinguishable from Skynet, from the Terminator series, right? Because
yeah, this seems scarier. Like I'm way more dubious that we've sufficiently mastered what neurons in the brain are actually doing, and we just need to.
Yes, yeah, that's a good point. That's a good point because here's what they're doing now. This is called Alpha Learn, I think is what they were calling it. Yeah, I don't remember what this is called, but I think it's Alpha Learn. They basically are moving this technology, this creative reinforcement learning model, and moving it into simulated 3D spaces that have, physics modeled in the way that we understand physics in our real world.
Are they hooking it up to the stoplight? That's what
I think that what's going to happen
No
is
internet access, that's just the one rule here.
What?
That's
Sounds
just
like
really
relation to a banjo.
Oh, yeah, true.
maybe.
Isn't that how it's kind of escaped? That's what I remember.
Right, but
It's
all
like,
I'm
okay,
saying,
it's
all
the
I'm saying
stoplights.
is, I don't think it matters if we hook it up to stoplights. What's going to matter in a few short iterations if it wants to hook up to stoplights, and if we're going to be able to stop it. Right?
Yeah, it'll probably just troll some engineer into doing it for them.
Exactly. Well, or as people will just, yeah. So anyway, this is 15 minutes. I know we're almost out of time, but I'm just going to play this anyway. You can see this.
Let's see what we're up against.
Okay, I'll go ahead and just play it on fast.
It looks like there's a lot of commercials, maybe.
They're just the sections of the video.
Oh, hopefully.
Hand authored.
Hand author, never seen during training. So it's a tag fiesta. All 3 players are rewarded when any of the players are not touching any of the floors. So they do have an ability to shoot.
Oh, they're giving guns to operate. That's smart.
So what does it mean to not be touching the floor?
The yellow? The green?
I think it's the red. I think it's, I'm not sure actually.
Oh, just one of the colors. It just needs to.
Yeah.
Or it's rewarded when. Okay.
It does say there's a reward there for even the green.
Is this?
Oh, they can lift each other off the floor.
I don't know why it keeps blinking like that.
Oh.
The player is rewarded when they're on the white floor and the other player is not on the white floor.
Okay, so it's
So we're seeing how fast it learns that, or?
So they didn't tell it the rule. They
We did
just-
not, we,
Just let it.
just the reward.
just the reward,
They
yeah.
just wander up on the white hill and get a treat.
So they haven't even found the white hill yet.
Yeah.
And now he's found it.
He's like,
He's
that
getting
feels
the
good.
reward.
Oh yeah.
And he stays
Oh
there.
yeah.
He's like,
wait, no, it stopped.
I like that.
Wait, did it kick the other guy down on him? Oh, he
Oh.
shot
They
him.
shot him.
Yeah, he's now
Bad idea. Bad idea.
The blue player is rewarded for seeing the red player, and the agent is rewarded for not being seen by the blue player, the red agent.
I guess
So it's hide and seek.
these guys are trash can.
Wow, that first person view.
Getting old.
The red agent managed to get some distance from the blue agent.
Oh, hide in the corner, hide in the corner. It's concentrate.
Or did you just block it off?
Well, that would have been the smartest thing I've ever seen. Green is secret and blue.
So it's a 3-player example.
Oh, he's trying to go high. Nice, yeah. It's interesting, the green has learned to follow him around so he doesn't leave his sight.
Oh, wow.
The purple and black cube are both touching the agent's floor color, so it's capture the flag. So red needs purple and black to be on red, blue needs purple and black to be on blue.
So it was
Wow.
nice. Zap.
I swear I played this person in video games.
How long does it take for that, for it to learn these?
That's a really good question.
This is kind of crazy
Is
because
this like the first try?
this is like multi-step, right? Like
Yeah.
it has to know to pick it up and take it back.
Yeah, I don't know how much these have been trained, but all the other stuff that I can see on the other things,
And he's defending it. Did you
Yeah,
see
the
that?
first time you hit the bed, the second time you hit it.
but it is a lot of processing power. So it is a scale issue for these things.
So it's just find its base. What's it trying to do?
It's trying to find its gray color
Because
base.
I think this is like, it gets rewarded when it puts it on the base, right?
I see it.
Oh, is this still capture the flag?
Yeah,
Yeah.
there's a one flag CTF.
One flag.
Wow, I can't believe we can
Dude, turn around, turn around.
do that. No good.
Yeah.
Yeah.
Eventually they learn to.
We haven't actually created campers yet, but they're
Yeah.
coming.
They haven't learned.
Oh, just threw
Oh,
it.
he threw it.
Yeah,
What the?
it's learning to throw 'em. Both agents are rewarded for getting the black sphere, yellow sphere, black pyramid, and purple cube, all near something.
Chuck that.
So like, does it tell them, it probably tells them this is the objective, and then they figure out how to do it.
No,
They-
it's just when they randomly do it, it gives them a treat.
Yeah, it's just a reward base.
So they just start doing stuff and
They
then
just start
go,
doing stuff, yeah.
So these are after they've been trained. This is-
Yeah.
It
Yeah.
would be really boring to watch the initial.
The training would be more
the
in there.
initial models.
Oh, I see, so they train them for a long time, and then they
Yeah.
throw them every
So
time.
are the rewards just like Boolean, like yes or no, or do you think it has like a spectrum? of,
I imagine it's
How
scored.
much the reward
It's
is.
scored depending on how much, and that is, that for any reinforcement model, the scoring, the actual reward is really where the big key is.
Yeah, that's
I mean, you have to have the right reward. And I guess that's, I mean, I don't know, like, if they're gonna actually become true human agents, I don't know, what's your reward versus my reward, right? We
Yeah.
have different opinions there, right? Yep, thanks for coming. There was one we did see the one where he was like throwing stuff around, right? Yeah, that one was pretty surprising.
The first time I saw one of them like change his behavior, like he has it and then he gets shot and then he has it again and he kills the other guy before he can go get up.
Yeah.
Like that was.
That's good, this is like,
Spawn camping. Spawn camping.
run for your life. Oh, that's cute, it can't keep it up the hill. Why does it only go? Like,
Is the reward for when it's rolling down? Or,
I think there's a reward for it touching.
this is keeping it upright, I think.
I think it's,
Oh.
Oh my gosh, that's brilliant.
one of the cubes has to be near the other, but like not near the other one. So like,
It's really having a hard time figuring it out. This is ordering it pretty much.
yeah. So then in order to take reinforcement learning and make general intelligence out of that, you would like, the real thing is like, what's the reward mechanism
Yeah.
for general intelligence, right?
that's exactly it, yeah. Which is, I think, it's a harder problem, but the point is that's one that you can, I mean, if you can, if you went and talk to economists, they'll tell you that there's something called a homo economicus, that everybody is optimized towards financial outcomes and whatnot. It's not true, but that's probably a place to start, you know.
Earn
Is it-
money.
I mean, it
Yeah.
seems like, I don't know, it seems like defining success at life
Yeah.
is such a hard thing that if you could just solve that on its own, like you're already like super famous, right?
You're probably writing books and giving seminars, right? Yeah. No, but that's
How
true.
educated, actually.
Well, it's true if success at life is identified by a new species as getting rid of the other dominant species, then there's a very clear goal there.
Sure.
Well, and if you look at evolution and stuff, it could just be boiled down to just propagating, right? Continuing.
Yeah,
Yeah, because of reproduce.
it's a good point. It's a good point. Which could create other problems. Maybe they'll reproduce in Alpha Centauri or something. Send them to a different place.
Did he help him get up there?
Yeah.
We need computing resources. That's problem.
True. I guess you just create a reward mechanism for creating computing resources.
Yeah.
And they'll create their
So
own.
shoot robots into space. That work. That was
That was cool. Thank you.
that was
Yeah.
cool.
Thanks for coming.